on this paper.
Can I ask a question?
Yes, absolutely.
I just wanted to ask you, how do you quantify the cost per meter alpha in your simulations? So do you consider reconfiguration times measured on real optical circuits, or you just select it empirically?
That's a very good question. So for us, we mainly see the cost as a time, actually. So alpha could be reconfiguration time, which is something like milliseconds. And packet forwarding is like nanoseconds. So that's kind of the way we see it with the alpha, but it's a model question. So this is a choice we made, but yeah, it's the sum of the two costs, basically. So it's parameter of the model here.
Okay, thank you very much.
You can also see it as a energy cost or something like that, but we see it mainly as a time cost here in this context.
Thank you.
Okay, any other question? Well, I was wondering if in the case where we have more than B flows, roughly of the same intensity, what would happen? Can we expect an oscillation in the configuration of the optical switch?
Right. So here the idea is, of course, that if you have many flows, that some of them that are less frequent, they go on the static network that we have in addition, that we really use these B links for the elephant flows directly. But there is some issue, of course, or concern that you can have some thrashing, like you have it in an operating system cache or something like that. We didn't observe that in our experiments with the workload, but this is maybe the price you have to pay if you're like decentralized in this choice. But so far we didn't confirm that this could be an issue here. But it's a good point. It's something to be careful about.
Okay.
I also have a question here. Excuse me.
Please.
So
please go on.
Yeah, for your B matching, I don't know if B is larger, it's either to approximate, or B smaller is either to approximate.
Right. So currently the competitive ratio that we have is indicating that the higher the B, the harder it is to be online competitive, right? Because yes. Now the intuition is that there is more to optimize. You have like a higher degree of flexibility. So now the offline algorithm can also do more. But yeah, that's kind of the intuition here, why a larger B makes it harder for the online algorithm. It may be a little bit different if you have like some kind of resource augmentation model, so that the online can use one or two more links than the offline. Then this is like in caching, then usually the competitive ratio gets constant. But this we would still need to investigate.
Okay, thank you.
Any other question?
But it's also not quite clear what is the best caching strategy here, whether it's like LRU is still good here in this context, or whether kind of different strategy would be better. It's one of the open problems in this context, I think, in practice.
Well, that's a very interesting point.
I just realized now. So this competitive analysis we have is kind of, it works more or less for many eviction strategies, but which one is really better, we don't know currently in practice.
Okay. If there are no additional questions, I think this concludes our session.